Assalamu alaikum warahmatullahi wabarakatuh. I'm Ahmad Shabil. My metric number is 1824143. In our group report, I have discussed the property of the hash function for cryptocurrency and the combined application of blockchain and hash. So now let's begin with the hash. In a simple word, hashing is a mathematical function that takes any length of input and produces a fixed length encrypted output. Bitcoin uses a secure hash algorithm called SHA-256. Whatever the size of input is, the output always be 256 bits long. This is important when working with massive amount of information and transaction. Rather than remembering a big amount of input, the system can track it by remembering the hash value. The ideal cryptographic hash function has six properties that make it secure. The number first one is collision resistant. There are no guarantee for collision free hash function algorithm, but cryptocurrency and blockchain system should include a unique value with the data to make the system collision free. And the second point is the cryptographic hash should be puzzle friendly. Number three, it should be deterministic. So what is meant by deterministic? The hash result will always be the same for the same input regardless of how many time we enter the same input. Number four is any change in input, even if it is just a single letter, must produce different result. And number five, it to facilitate computation, the function should be fast enough. So it should be quick uh, computation. And the number six is pre-image resistance. It is infeasible to determine what is input by looking at the output. That means it is secure, means the hash function is secure, but how it is secure? We can take some example. So, for example, if we want to find a message whose SHA-256 hash is some specific string of 256 bit, we have no better method than to just guess and check random message, and this would require one average 2 to the power 256 guesses. Now, this is a number so far that it can be appreciated for the size, but let's give it a try. 2 to the power 256 is the same as 2 to the power 32 multiplied by itself 8 times. Now, what nice about that split is that 2 to the power 32 is 4 billion, which is at least a number we can think about, right? So, what we need to do is appreciate what multiplying 40 billion times itself 8 successive times really feels like. The number is huge, so we need to use this huge number for brute force attack to break down the SHA-256. This is not possible in our real life. Now let's we can talk about blockchain and hashing. How this blockchain and hashing, these two systems combinedly work in the cryptocurrency system. So a blockchain, as the name suggests, is a chain of information containing blocks. This technique was first described by a group of researchers in 1991. However, it remained largely unutilized until Satoshi Nakamoto adapted it to Bitcoin in 2009. A blockchain is publicly accessible distributed ledger. They have an integrating property. Once data is recorded inside a blockchain, it is extremely difficult to change it. So, how exactly does this work? We can take a close look at one of the blocks from the chain. Every block stores some data, including the hash of its own block and the previous block of the hash. The data stored within a block is determined by the type of blockchain. For instance, the Bitcoin blockchain stores transaction details such as the sender, receiver, and amount of coins in it. A block also has a hash. A hash can be compared to a fingerprint. It is always unique and identifies a block as well as all of its content. The hash of block is calculated after it is created. The hash will change if something inside the block is changed. As can be seen, it is very useful for detecting blockchains. A block is no longer the same if its fingerprint changes. So here we have a chain of three blocks. As you can see, each block has a hash and the hash of the previous block. So block number 3 points to block number 2 and block number 2 points to block number 1. Now let's say that you tamper with the second block. This causes the hash of the block to change as well. In turn, that will make block 3 and all following blocks invalid because they no longer store a valid hash of the previous block. So changing a single block will make all following blocks invalid. But using hash is not enough to prevent tampering. Computers these days are very fast and can calculate hundreds of thousands of hashes per second. You could effectively tamper with a block and recalculate all the hash of other blocks to make your blockchain valid again. So to mitigate this, blockchain have something called proof of work. It is a mechanism that slows down the creation of new blocks. In Bitcoin case, it takes about 10 minutes to calculate the required proof of work and added a new block to the chain. This mechanism makes it very hard to tamper with the blocks because if you tamper with one block, you will need to recalculate the proof of work for all the following blocks. So that's all from me. Thank you. Assalamu alaikum.